At first, Pereira looks completely normal. Then the entire city begins to move. Then one structure fails, and thousands of tons of concrete come crashing down.
The street disappears beneath a wall of concrete. But someone may still be alive inside.
Now the rescuers face something terrifying. Moving the rubble could bring the building down again.
And beneath this mountain of concrete, rescues are listening for a sound that could change everything.
Quiet.
In Pereira, the shaking was powerful enough to bring structures down, turning streets into dangerous fields of concrete and steel.
But beneath the concrete, the most important question was no longer how much had collapsed. It was whether anyone was still alive. At 7:34 that morning, Colombia was hit by a magnitude 7.4 earthquake, and Pereira was among the cities facing the consequences. The epicenter was not in Pereira. It was hundreds of kilometers away, near San José del Palmar in Choco, yet its energy reached deep into Colombia. By the time those seismic waves reached Pereira, the danger was no longer underground. The entire city had to absorb their force. An earthquake can last only seconds. But inside a building, those seconds can become a fight against every force holding it together. Above ground, the damage was visible. Below it, the earthquake had already created a far more dangerous problem: unstable structures. When the shaking stopped, Pereira faced a different kind of danger. Knowing which damaged buildings could still stand and which could not.
Pereira was now facing the physical evidence of the earthquake. Collapsed structures, damaged streets, and a rescue operation growing by the hour.
Among the concrete, the numbers became human. Families waited behind barriers, while rescues searched for signs that someone might still be alive. Every piece of rubble became a decision. Move too much, too quickly, and an unstable void could collapse before rescuers reached it.
Beyond the barriers, another kind of rescue was unfolding. Families could do nothing but wait, listen, and hope for a name.
Command to base, Sector 4 is clear.
Outside the rubble, the response had to become a machine of its own. Rescue teams, engineers, equipment, and decisions moving together.
Some buildings were damaged but standing. Others had already failed. And rescuers had to approach every one as if it could move again. Then, nearly 38 hours after the earthquake, rescuers found something they had been fighting for: a living survivor beneath Pereira's rubble. Her rescue was not quick. With her arm pinned, rescues worked for roughly 10 hours to free her from the wreckage.
After nearly 2 days beneath the rubble, Daniela emerged alive. For rescues and onlookers, the silence finally broke with cheers.
One survivor had been found, but across Colombia, hundreds were still missing, and rescue teams could not stop searching. Some rescuers were professionals. Others were ordinary Colombians who refused to stand outside the rubble and simply watch. Sometimes, the most important rescue machine is the one that stops. Silence can give a buried survivor a chance to be heard. Then came another threat. Rescuers could not control. Aftershocks, capable of shaking already weakened structures, all over again. By now, the rescue had become a delicate balance. Human hands searching for life, and machines powerful enough to move mountains of rubble. Some searches depended on technology. Others depended on something far older, a trained nose moving through the darkness.
Then everyone stopped. In a disaster this loud, even the faintest sound could change the entire operation.
But the destruction of ground began with something invisible below it, seismic energy racing through the earth and shaking structures from their foundations upward. A building is not rigid against an earthquake. It moves. The question is whether that movement stays within what its structure can safely absorb. When forces concentrate in one weak element, the damage can spread. A single failure can become a chain reaction through the structure.
Now the machines took over. But even the largest excavator could not simply tear through the wreckage.
Hold it right there.
Then came one of the most dangerous moments, lifting tons of concrete without letting the structure shift around it.
Underneath, a space appeared where solid concrete had been. For rescues, a void like this could mean danger or possibility.
Rescuers were searching through a structure they could barely see inside. Technology had to turn darkness into information. An excavator could move mountains of rubble. But inside the collapse, another machine was needed, small enough to reach where humans could barely fit.
Every slab had weight. Every piece of steel carried force, and every movement had to be calculated before the rubble could be touched.
Before the next machine moved, engineers had to answer one question. Could the structure withstand the movement without failing again?
Only after the structure was assessed could the operation continue. Slowly, the crane began moving the next piece of the city.
Beneath the rubble was another battle, one engineers had been studying for decades: how buildings absorb the violent movement of the ground.
Columns carry enormous loads. During an earthquake, they must carry those loads while the entire building is being pushed sideways. Buildings survive when their structural elements work together. The connection between beam and column can become one of the most critical points. And the shaking is not one simple movement. Different seismic waves arrive with different motions, forcing structures to respond again and again. Every structure has natural patterns of movement. When earthquake motion aligns with those patterns, the demand on the building can increase dramatically. But an earthquake does not care how a building looks. It tests the entire load path, from the ground beneath it to the highest floor. The foundation is where the building meets the earthquake. If the ground moves violently, everything above must respond to that movement.
Concrete is not the only material at risk. Masonry walls can crack, fall, or change how a structure carries earthquake forces.
Back at the collapse, engineers could read the evidence: broken concrete, bent steel, displaced walls, and the pattern of failure left behind. The question was no longer only what collapsed, it was why, and whether the same weaknesses could threaten another building somewhere else. To understand the destruction, we have to leave the rubble behind and travel beneath the country itself, to the forces shaping Colombia. Colombia sits in one of the world's most active tectonic environments, where enormous plates interact beneath the surface.
An earthquake begins underground, where accumulated stress is released suddenly and seismic energy races outward in every direction.
Those waves eventually reach the surface, and when they meet buildings, roads, bridges, and people, invisible energy becomes physical motion. The magnitude tells us the earthquake's size. But magnitude alone cannot tell us how much damage a city will suffer. More than 100 kilometers beneath the surface, the earthquake began. That depth would shape how its energy reached the cities above. Above that hidden source was the region near San José del Palmar in Chocó, the geographic starting point of this national emergency. Pereira was not at the epicenter, but it was close enough to experience severe shaking and serious structural damage. In the first hours, the numbers changed rapidly. Damage assessments expanded, buildings were inspected, and rescues searched for people still unaccounted for.
Across the hardest-hit areas, the mission became larger than one building. Every damaged structure had to be assessed, searched, and made safe.
Then daylight began to disappear. For rescue teams, the rubble was becoming harder to read, and every hour made the search more demanding.
Sometimes the most important rescue tool is not the largest. It is a microphone, searching for the faintest sound beneath the concrete.
Human senses have limits. Specialized search dogs can examine spaces rescuers cannot safely reach, using scent to guide the search.
Then something unexpected can happen in a rescue zone. The biggest machines stop, because the smallest sound suddenly matters more. Then, in Pereira, the search became more than a possibility. Rescuers were finding signs that people could still be alive beneath the rubble. One of those stories was Daniela Largo, a 32-year-old woman rescued alive after becoming trapped beneath the ruins in Pereira. Getting someone out was only half the battle. The surrounding structure had to remain stable, while rescues created a path to safety.
By August 12th, Pereira's reported tally included 243 people rescued, but 45 people were still missing.
For every rescue, another search remained. And beneath Pereira, the clock was still moving. Pereira became the center of the rescue story. But the earthquake had shaken a much wider part of Colombia, far beyond one city.
When the ground moves, the damage doesn't stop at buildings. Roads, bridges, slopes, and lifelines can become part of the emergency.
Colombia's mountains create another challenge. When slopes are destabilized, reaching isolated communities can become as difficult as the rescue itself. An earthquake can damage the systems people barely notice until they stop working: water, electricity, communications, and transportation. And hospitals face a brutal contradiction. During a disaster, they must remain standing precisely when the surrounding city needs them most. Under every street is another city. Pipes, cables, drainage, foundations, and connections that can determine how quickly a community recovers. For communities beyond the major cities, distance can become another enemy, turning damaged roads and difficult terrain into a race against access. Before residents can simply return, engineers must answer a harder question. Is the building damaged or dangerously unstable? A building can look intact from the street and still hide serious damage inside. That is why the inspection comes before the return. Now comes the question that matters most. Why can one building survive violent shaking while another nearby suffers devastating damage? Start with the columns. They carry enormous loads every day. And during an earthquake, their ability to deform safely becomes critical. Then there is resonance. When ground motion interacts with a building's natural rhythm, movement can become dramatically amplified. Inside reinforced concrete, steel and concrete work together. The details of that connection can determine how a structure behaves when the ground suddenly moves. And everything eventually reaches the foundation. A building can only perform as well as the system transferring its forces into the ground.
Behind every resilient structure is a set of rules. Seismic design standards intended to keep buildings from becoming brittle. When the ground moves,
one word matters enormously in earthquake engineering: ductility, the ability to deform, absorb energy, and avoid sudden brittle failure. Sometimes the weakness is not the whole building. It can be concentrated on one level, creating a dangerous imbalance when earthquake forces arrive. But design is only part of the equation. The final structure depends on materials, workmanship, detailing, inspection, and how faithfully the design is built. The lesson is uncomfortable.
Earthquake resilience is not
Created by one feature. It is built through hundreds of decisions, made long before the shaking begins.
then, almost as suddenly as it began, the violent motion ends. But for those left behind, the real crisis is only beginning.
For rescuers, silence is not necessarily the end. Every void has to be checked carefully before hope can finally disappear. Beyond the barricades, families wait for information. For them, every passing minute can feel impossibly long.
While rescuers search for people, engineers are already thinking about tomorrow. Which buildings can be repaired, and which may never be safe again.
Rescue may be measured in hours. Recovery is measured differently, in months, years, and sometimes an entire generation. After the sirens fade, the city is left with a different kind of work, measuring what was lost, what can return, and what must change. Every damaged structure becomes evidence. Engineers study those failures because the next earthquake will not wait. For anyone to be ready.
Preparedness is the lesson left behind. Stronger buildings, better planning, faster response, and communities that know what to do when the ground moves.
An earthquake may last only seconds, but those seconds can expose decades of decisions and change the future of a city forever.
Colombia will rebuild, but the question left beneath the rubble is simple. When the ground moves again, will the lessons remain standing?